Today's experiment is clamping circuits. It is the circuit that clamps a signal to a different DC level without affecting its shape. It is also known as DC restoring or DC inserting circuits. They are commonly used in the TV receivers for restoring lost DC levels in signals from the transmission. Now let us see the circuit diagrams. The first one is the positive clamper at 0 volt. From the circuit diagram we can see that a capacitor and diode is connected in series with an input voltage of 20 volt peak to peak sine wave. The capacitor here used is an electrolytic capacitor with polarity of 10 microfarad value. The positive side of the capacitor is connected to the cathode of the diode. Hence we are using an electrolytic capacitor with polarity. Care must be taken while connecting the leads to the circuit diagram. Next we are going to see the input and output waveforms. This is the input waveform of the circuit. Here we are giving a sine wave of 20 volt peak to peak 1 kHz to the circuit diagram. From the output waveform we can clearly see that the entire input voltage of 20 volt is clamped or shifted to above the positive level. But in practical, a 0.5 voltage drop across the diode will remain below the reference level. So the total voltage above the reference level must be 19.5. This is the transfer characteristics of the circuit. The transfer characteristics is the relationship between the change in output with respect to the input. Here from the transfer characteristics curve, we can see that the voltage above the reference level is the 19.5 voltage and the voltage below the reference level is the 0.5 voltage drop across the diode. Next one is the negative clamper at 0 volt. Here also a capacitor and diode is connected in series, but with a change that the negative lead of the electrolytic capacitor is connected to the anode of the diode. The input remains the same as 20 volt peak to peak sine wave. See the output waveforms. As in the positive clamper, it clamps the output entirely to the positive side. The negative clamper clamps the output entirely to the negative side. But in practical, a 0.5 voltage drop will remain in the positive side and the remaining 19.5 lies in the negative side. This is the transfer characteristics. It is clearly seen that the 19.5 voltage remain in the negative side and the voltage drop lies above the reference line. This is the wired circuit diagram of positive clamper at 0 volt. The capacitor and diode is connected in series. The input is given to the negative lead of the capacitor. The positive lead of the capacitor is connected to the cathode of the diode. The 20 volt peak to peak 1 kHz sine wave as the input is given from this function generator to the circuit. The output of the circuit is taken across the diode. Now let us see the waveforms. This is the input waveform. 20 volt peak to peak input waveform. 1, 2, 3, 4 divisions into 5. That is equal to 20 volt peak to peak sine wave. Now let us observe the output waveform. For that we have to switch on the channel 2. And then we have to select the ground reference line of the output waveform. The ground line of the input waveform and output waveform must be in the same reference line. Then we have to select the coupling in the menu from AC to DC for viewing the clamped output. This blue color waveform is our clamped output. From this we can clearly see that the entire waveform is shifted to the positive side of the graph. And then we can see that the 0.5 voltage drop across the diode will remain in the negative side of the waveform. Next we have to observe the transfer characteristics of the circuit. For that we have to switch on the display button and select the format from YT to XY mode. This is our transfer characteristics. For working as negative clamper at 0 volt, we have to change the polarities of capacitor and diode in such a way that the negative lead of the capacitor is connected to the anode of the diode. Now let us observe waveforms. From this we can clearly see that the entire input voltage is shifted to the negative side. But a 0.5 voltage drop will remain above the reference line. Now let us observe the transfer characteristics by changing the format from YT to XY mode. This is the transfer characteristics. From this we can clearly see that the 0.5 voltage drop above the reference line and below the 19.5 voltage. Next one is the positive clamper at minus 3 volt. If a positive clamper circuit is biased with a negative reference voltage, that voltage will be added to the output to raise the clamping level of the circuit. Here a positive clamper circuit is connected with a minus 3 voltage in series with the diode. The negative lead is connected to the anode of the diode. Now let us observe the output waveform. This is the output waveform. From that we can see that the NDA voltage is shifted to the positive side with a minus 3.5 voltage will remain on the negative side with a voltage drop of 0.5 volt. The balance 16.5 voltage lays on the positive side. This is the transfer characteristics. From this we can clearly see that the minus 3.5 lies on the negative side and balance 16.5 on the positive side of the cara. This is the wide circuit diagram of positive clamper at minus 3 volt. The capacitor and diode is connected in series with the cathode of the diode is connected to the positive lead of the capacitor as in positive clamper. For giving minus 3 volt supply, we are using an external power supply. The positive lead of the power supply is connected to the common ground terminal of the circuit and the negative lead of the power supply is connected to the anode of the diode. The input is given to the minus lead of the capacitor and output is taken across the diode. Now let us observe the waveform. This is our input and output waveform. From this we can see that the output is entirely shifted to the positive side and some voltage remains in the negative side. It is 0.7 divisions into the 5 that is equal to minus 3.5 voltage, including the 0.5 voltage drop will remain in the negative and the remaining 16.5 voltage lies on the positive side of the waveform. Now let us observe the transfer characteristics. For that we have to change the format from YT to XY. This is the transfer characteristics. It is also seen that the minus 3.5 lies in the negative side and the remaining 16.5 on the positive side. Next one is the negative clamper at plus 3 volt. Like said in the previous circuit, here a negative clamper is biased with a positive 3 volt supply for raise the clamping level. The positive lead of the power supply is connected to the cathode of the diode. This is the output waveform of the circuit. Here the positive 3.5 voltage shifted to the positive side and the remaining 16.5 lies on the negative side. The 3.5 voltage include the voltage drop of the diode. This is the transfer characteristics. It is from plus 3.5 to negative 16.5 voltage. Next one is the positive clamper at 3 volt. This is the circuit diagram. A positive 3 volt supply is connected in series with the diode to apply the reference voltage to the circuit. The positive lead of the supply is connected to the anode of the diode. Now let us discuss about waveform. This is our output waveform. Here we can see that the output is entirely clamped to the positive side. The clamping starts at a level of 2.5 voltage and ends at a level of 22.5 voltage. But in theoretical case it will be 3 volt to 23 voltage. But here while considering the voltage drop across diode, it will be 2.5 to 22.5 in the positive side. This is our transfer characteristics. Here also it will start at 2.5 and up to 22.5 in the positive side. This is the wide circuit diagram. The cathode of the diode is connected to the positive of the capacitor. The positive lead of the plus 3 volt power supply is connected to the anode of the diode and negative to the common ground. Now let us see the waveforms. This is our waveforms. The below shows the input waveform 20 volt peak to peak sine wave and above shows the output waveform. From this we can see the shift starting at a point of 0.25 into 10 volt, that is equal to 2.5 volt and up to a voltage of 22.5 in the positive side. Next, for seeing the transfer characteristics, we have to change the format from YT to XY. This is the transfer characteristic. It also lies between 2.5 to 22.5 in the positive side. Next one is the negative clamper at minus 3 volt. Here a minus 3 volt power supply is connected to the negative clamper circuit. As it is a negative clamper, the power supply leads are connected in a way that the negative lead of the supply is connected to cathode of the diode and positive lead to ground. This is the waveform, output waveform. Here the shift starts from a voltage of minus 2.5 to minus 22.5 in practical while considering the voltage drop across diode. Theoretically, it will be minus 3 to minus 23 volt. This is the transfer characteristics. It's also lies between a voltage of minus 2.5 to minus 22.5 practically in the negative side.